and I'm really glad to be hosting the Q&A for this Winter Systems at Scale 2022 edition, in which we'll dive deeper and ask the questions we've received. Before we get started, I would like to thank all of our speakers for the really great talks and for sharing all this information so that everyone in the industry can benefit. I've learned a lot, and I'm sure our viewers have too. First, I would like to ask our speakers to briefly introduce themselves, and I will go in the order of the talks we just had. First up, Salim.
Hello, everyone. I'm Salim Virji, a site reliability engineer at Google, where I've worked primarily on distributed storage and consensus systems.
Thank you. Sayak.
Hello, everyone. I'm Sayak Kundu. I'm a software engineer in the serverless computing team over here at Meta. My area of interest includes distributed systems with a focus on reliability.
That's great. Thanks, Artem.
Hey everyone, my name is Artem. I'm also a software engineer at Meta. And my biggest interest is also distributed systems, streaming type of systems and queuing infrastructure. Thanks for listening to us and welcome to Q&A.
Thank you. Nathan.
Hey there, everyone. My name is Nathan Sullivan. I'm a production engineer here at Meta. I've been with the company about 3 years and really just passionate about working on workflow automation solutions and providing those solutions to our network engineers.
Thank you. Nikita.
Hey everyone, my name is Nikita Vitoshkin. I joined Meta not so long ago, and I try to bring people and automation to work together.
That's great. Thank you. Nikos.
Hello, everyone. I'm Nikos. I'm a software engineer based in London. I work at Expedia Group, where I have been involved in different areas, including web engineering, developer productivity, and even more recently, reliability engineering.
Thank you. Kaushik.
Hi there. My name is Kaushik. I'm a media within the reliability space with Expedia. I've been like Nikos in various spaces under distributed systems, edge platforms, and reliability engineering.
Thanks. That's great to hear so many people are working on reliability. Thanks. And last up, Surupa.
Hi, everyone. Thank you for tuning in today. I'm Shurupa. I'm the core systems lead at Meta. I work in our infrastructure group with many of the people who you just got introduced to.
Yeah, that's great. Thank you all. And for all our viewers, thank you so much for watching so far. If you have questions, please continue to ask them in the Zoom webinar, and I'll try to ask them here. Okay, we'll first start with the questions we've received before. Salim, you are first up. First, I want to mention that I've noticed that you started as an SRE at Google in 2003. This is almost 20 years ago, and if I'm not mistaken, is when SRE started. So you must be one of the first SREs ever. We're really grateful that you could share all of your experience in this System at Scale edition. So thank you for that.
Thank you. It's a pleasure to be here.
Yeah, thanks, Salim. For the question, in your talk, amongst effective resource management practices, you recommend building a good dashboard and to use the use method. Could you detail more what this method is?
Yeah, the use method, it's an initialism where the USE stands for utilization, saturation, and errors. And these are fundamental metrics that I encourage you to collect. And I didn't come up with this method. It's a well-known method in telemetry. But I encourage you to use it because it provides a really fundamental baseline for understanding the resource consumption of your systems. And you can refine the metrics that you have once you have this baseline. But with the use method, you get a very basic cost per request metric that you can then use to say, all right, so each of our requests that goes into this bucket costs us this many CPU seconds. And all sorts of really insight will flow from that. And you'll also understand then where else you want to add measurements and then how to take those measurements and understand resource consumption. But starting with the use method is something that provides a very good baseline.
Mm-hmm. Yeah, that's great, really great. So understanding the resource use per request. Okay, yeah, thank you for that. Okay, so next we have a question for the talk from Sayaka and RTM about our asynchronous computing. We know that our async tier is very, very important. It's a very important system at Meta, and it has been evolving a lot, especially in the last years. And now it's supporting using streams. So we have a question about streams. If streams are so effective, why does the asynchronous computing platform not migrate entirely to use it as an internal storage?
All right, I can take that. So streams are effective, yes, and they are cheap as well, but it comes with a trade-off of flexibility, as we have already explained in the talk. At the end of the day, it's more of a question of command versus events as we look at it. For event-driven workloads, streams are definitely a good fit, and users in most of the cases already have their workloads on stream instances or topics, and we enabled our platform to integrate with these instances. However, for workloads originating from commands, it's more seamless to buffer them in queues within our platform. And this is because of the various benefits that queues provide. So, yeah.
Mm-hmm. Yeah, thanks for that. So it does depend on basically the use case. It doesn't fit everything. Okay, thank you for that. So we have another question for this talk. What are the next set of challenges that you expect to see in the future for the async computing platform?
Yeah, I can pick this one. Essentially, obviously, all the time we're looking at efficiency wins, and we will continue doing this. This is the first area. And the second area is more around generalizing the infrastructure more, which also aligns with Surupa's talk and the ICSP and all the initiatives around. What we're trying to do is we're trying to transform from the single function as a service platform to something more generic, which would consist multiple serverless building blocks that customers can combine together and apply flexibly depending on their use case. So far, this seems like a biggest next goal that we look forward. And for example, one good example could be event and action framework. Instead of having just triggers that run functions on our platform, we can generalize it to have event catalog, multiple different event sources that customers can discover, and different actions that they can take. Not only run functions, but many others, like start a container, start some other jobs in different runtimes. This, like generalizing it and making it composable, it seems like the next big challenge to us.
Mm-hmm. Yeah, that's really great. And yeah, Surupa does mention that, and we care a lot about that in our infrastructure. That's the only way we can keep growing. Thank you. So next up, we have questions for Nathan and Nikita's talk about network workflow automation. It was a really great talk, and really the layer at which you operate is so critical, as we all know here at Meta. The question is about the language that is supported. Can users write building blocks in languages other than Python?
I'll take this one. So yeah, that's a really great question. What we're trying to do is expose, a language agnostic platform. So since we use the POSIX API as basically our interface into client code, we can support additional languages. And that's one of the things we're looking at doing going forward. Python's pretty common among our network engineers. They tend to be pretty familiar with Python. However, we are exploring, Go as well as Rust. And since we're just bundling that into a binary and executing it, there's no problem as far as the API interface goes in supporting those languages. So we hope to add that in the future.
Mm-hmm. Yeah, that's great. For sure, Python is used a lot here. So the second question for this talk, is this platform network specific?
Yeah, I'll try to take this one. No. Like the basic ideas when you have a workflow as a service, when you can quickly build a workflow and ship it to production, and have a generic building blocks that can create tasks, being an engineer or performer, like a switch reboot. The idea is generic, and for the most part, like our decider, it's interpreted as pretty generic. However, we have a large number of building blocks and some validations, for example, to check that this input field is a valid host name, etc. And our library of building blocks is targeting our network requirements. So otherwise, no. And I think it's pretty rich idea, and we'll try to explore where we can apply it.
Yeah, that sounds really great if we can make this like workflow automation reusable in other places too. Yeah, thank you for that. We'll move now to questions for the Chaos Engineering at Scale talk from Nikos and Kaushik. I personally watched with great interest this talk, having been involved in evolving our infrastructure and making it more reliable. We know a tool like this is so important. The question that we have, it's a really great question, is can you provide examples of reliability issues you found through chaos experiments?
Sure, I will take this one. And I will start by hoping that we have found enough reliability issues to justify the investment on this platform. At Expedia Group, as we mentioned in the presentation, we are building our new runtime compute platform. And we have been running experiments with multiple teams, including platform teams, application owners who have onboarded their applications into the platform. We have encountered a number of reliability issues. Our worker nodes, let's start with that, are normally distributed across 3 or 4 availability zones, as we said in the deck. And when executing AZ failures in one of the clusters, the nodes, and as a consequence, any workloads, were not balanced across these AZs, which was an issue. Then as part of a similar experiment, we also noticed that certain core platform components, and especially agents or Kubernetes operators, did not have multiple replicas or literal lexion configured correctly to distribute across the AZs. Similar one, when executing failures to impact the inbound or the outbound traffic from nodes, we faced networking cases that would affect communication with tools such as ones for continuous deployment, observability, and this would essentially impact deployments and application monitoring. Then when we move to the applications point of view, as part of container and pod terminations, we found all sorts of issues, as you can imagine, from cold start and inconsistent startup times, which would impact the application's availability. And finally, I think resource saturation is a great example where teams did not really have a very good understanding of how the systems and services behaved. And by injecting CPU pressure to application pods, we identified issues with applications relying on CPU-based autoscaling.
That's really great. Thank you for those examples. We have another question for this talk. What challenges did you face when building and promoting the chaos engineering platform?
I can take this one. It's, as Nikos mentioned, was a huge challenge. We are building a new runtime platform. We're building a new CI/CD tooling at the same time, and we're trying to get teams to move on to these platforms, as well as introducing a new concept to them, which was chaos engineering. Integration was the biggest challenge for us. As most people know, when they're building systems which are in flight and still being developed, it's very hard to integrate and have concrete kind of APIs and platform kind of integrations. That was one of our biggest challenges. And because the landscape was always changing, it became very difficult for us to kind of commit to our own customers as to the CRDs that we were trying to produce or the actual APIs for them as well. So it's always that unusual challenge between the two where we were caught between both sides, being platform and application engineering teams. So that was one of our, I guess, our critical biggest challenges to keep up with both. Regarding the advocacy or the promotion of chaos engineering, it became clear to us that we need a program behind this once we had proven the value, as Nikos mentioned. And as you know, as we started seeing teams discovering either observability kind of gaps in their space or understanding of the systems, there was a lot more education required behind this. So the program definitely helped us in this area. Having a clear program and ensuring that you know who you're targeting and ensuring we have the content for the program, that was the biggest challenge, like asking engineers to curate content or come up with engineer level content for chaos engineering with blog posts and almost like seminars, I would say, or workshops, was a challenge for the engineering team as well as the leadership team as well. So those kind of things were always there for us. We're still on our journey. So watch this space as we kind of again explain how we get past the future challenges we have as well.
Yeah, this is really great, and this all sounds so familiar with having been involved in the reliability program at Meta. Yeah, it's the same. Like you need education, you need a program to track, you need to convince, and you need to basically drive onboarding to this better tools. Thank you. Okay, and now for our last talk from Surupa about building Meta's internal cloud. It's a really great talk, Surupa, and knowing internally how much design and how much thought and how much work has gone into ICSP. Really happy that we get to talk about it at this event. So we have a really great talk, a really great question. What are the biggest challenges you faced so far with InfraCloud, and how did you overcome them?
Yeah, thank you, Anca. I was smiling when Kaushik, you were talking about the challenges, and you said the people organizing ourselves, having the right information out there. We realized we needed a program. So I would say, even though the InfraCloud work is exciting from a technical perspective, the challenges have not been around designing the right architecture, I would say. The hard parts have been around changing how we work. In some ways, we are very good at what we do, and the present is pretty attractive. So I think changing how we've been operating so far has been the biggest challenge thus far. So I would say having a clear sense of purpose, knowing exactly where we're going, how we're going to take some incremental steps in this right direction. So you mentioned the InfraCloud Service Platform in particular, Anca, and this is a multi-year journey to build these. I think, Artem, you were referring to these composable building blocks. We are building these things incrementally, and then how to validate each of these incremental pieces with customers along the way, for instance, is one of the challenges. But someone joked that I see most things through the people lens, right? Because unlike many of the other people on the panel today, I'm one of the people managers participating in systems at scale. And I will say, kind of when you have a large group of people working towards a vision, some of the people related things like clear roles and responsibilities and making decisions in a fast and durable fashion, those so far have been the biggest challenges.
Mm-hmm. Yeah, that's really great. And it doesn't matter if we build like the best infrastructure if we don't get people to onboard on it. So the people aspect always matters. Okay, so now we'll move on to some questions we've received during the Q&A. So first we have a question for Artem. So this is for the asynchronous computing talk. What is the purpose of checkpointing?
So as far as I understand, this is about checkpointing in the stream. So essentially, let's say when we take items from the queue is stateful. So it does have some state, it does have some items inside. And when somebody is dequeuing these items and then hacking them, the items got deleted. So there is no problem with tracking progress of how fast you consume the queue. At the same time, for a stream, it's immutable. It's just like a log. So it's just a mutable long log, and all readers just keep the offset in the stream. And then they store this offset in some external place. And this is usually what we refer to as checkpointing. So essentially remembering where we stopped. So if we crash or something goes wrong, we can start from that particular place. This is what is the checkpointing, if I understood the question correctly.
Mm-hmm. Yeah, thank you for that. And we have another question for Nathan or Nikita for the network workflow automation talk. The question is, network is a shared resource. How do you slice and monitor the network resource usage or allocate across services?
Yeah, so that's a good question. So we actually operate across all of our different networks here at Meta. So that would include our production network, our FactNet, our management network. So we have a lot of different networks we operate across. But one of the things we do is we try to manage resources very closely using, both the Tupperware environments that we're running on, which allows us to control resources as far as CPU and memory. We monitor that. We do add auto scaling, But what we're doing as far as the network goes, we have additional systems in place that kind of monitor, the actual capacity we have in place. So whether that means, do we need to drain this, region per se, or can we leave it online if we're applying like updates, things like that. So there's a lot of different systems that come into play in managing, the actual services we have. But like I said, we're looking at all that as we're deploying new capacity, as we're, potentially draining regions. We have a lot of different data inputs that we look at.
Mm-hmm. Yeah, thank you for that. Okay, we have one more question that just came in. I think it's for everyone, because I don't think it's like for a specific one, or there is yeah, maybe it's for a specific one. So also for Nathan or Nikita for the network automation. What are the learnings and best practices for infra efficiency and capacity management at your company? Oh, I guess this is generic. So if anybody wants to chime in, like, please go ahead. I'll read the question again. So what are the learnings and best practices for infra efficiency and capacity management at your company? Oh, perfect. We have somebody wanting to chime in. Please go ahead.
One of the best practices that we have, it's two things I'll roll into one. Know how much you're using and have a clear forecast for how much you're going to use. And then the second part of that is something I alluded to in the talk, which is have a plan for what to do with resources that you've claimed but don't actually use. And so this means that you need to have an understanding of the entire ecosystem where your software is running and be compatible with nearby services so that you can release unused resources and free them for other services to use. Even if, say, the next day, because of your diurnal use pattern, you'll go back to using those resources. It's kind of a more holistic bin packing solution. So those are some of the best practices. And I could certainly go on, but I'd love to hear from other folks as well.
No, then this is really great. So have the visibility on how much you're using and then release what you're not using. So that will be auto scale, which, like we're doing this here at Meta. And I actually had a talk about auto scale, like I think 2 years ago, how we're doing. That is really important. Thanks, Nikita. Do you want to chime in too?
Yeah, one of the maybe unexpected things I learned is called Jevons paradox. It says, like, with increase of efficiency, when you start doing things more efficient, for example, you save like 5% of capacity, you increase performance, it will not save resources. They will be consumed. People will find new ways to consume those resources. So beware.
Yeah, that's a really good point. Yeah, thank you. Shrupa, you want to chime in too?
Yeah, I was going to say one thing that comes to mind is having the capacity be centrally managed and programmatic as much as possible seems to help. So, for example, every service owner has their own extra capacity that people keep for peak traffic, for instance. And the more programmatic we could be, so for example, if everybody could have a way to model the headroom capacity that they're keeping, that can really help to optimize the amount of extra capacity that every service owner is requesting for.
Mm-hmm. That is true. Being able to predict how much capacity you'll need, that is important. Thank you. Artem, your thoughts on this too?
Yeah, I can add a bit as well here. I think that everyone that, everything that people already mentioned is super important. I just wanted to give one silly advice. If you will always, in a large system, you will always have multiple ways to get some efficiency wins. And it's very important to be mindful and prioritize ones that give the most return from your investment, because it's very easy to get lost and start investing in a bunch of small things that would eventually help, but not really dramatically change things. So if you're planning to invest in some efficiency work, find the highest return of investment and put all the effort there instead of fragmenting it across many different areas. So far, this is my experience, especially in the large companies. You can really get lost very quickly.
Yeah, that's great. And I think Salim was mentioning this in his talk too, the economics of doing efficiency work. Like you do need to balance and choose the top ones. Thank you. And thanks so much for who asked this open questions. It was really great. And thanks for everybody chiming in. So we do have another question, which is for Sayak and RTM for the async computing platform. The question is, there was a distinction made between command versus event in response to a prior question. Did you see use cases where event results in a command being created by the customer? How do you determine the consumer's intent on whether the consumer is sending an event or a command?
I can try to answer this one. I think it's more like a formal it's more like a formal division between them. So there is no strict boundary, right? Whether it's a command or event, you can shape like literally any type of interaction that way. So there is no clear formal boundary. And in general, the event is, usually we refer to event if something is already there. Let's say there is a stream, somebody writes in there, this would be an external event that you consume. Or if we talk about command, it's essentially that you want to do something and you just want to do it in the background and put it in the queue. So this is but this is very vague separation, really. There is no strict rule and there is no need for strict rule. It's literally, you can use either of them, should be fine.
Mm-hmm. That's great. I think this is the last question we've received. I think we can wrap up here, but before we do that, I want to thank again all of our speakers. This was a really great discussion. So thanks for this and thanks for all the work and for the presentation. Thanks to our viewers. We appreciate your attention to this. If you have more questions, please continue to ask them. I think all of our speakers provide their contacts so you can reach out. Thank you all.